All right. Hello, folks. My name is Cy Venom, and I'm a developer advocate with AWS. Today, I am really excited to have Abhay Saxena on with me. Abhay, do you want to introduce yourself real quick?
Yeah, thanks, Sai. Hi, everyone. My name is Abhay. I'm a product manager with the AWS in-memory databases team. Excited to be here.
Awesome. So, folks, we're trying something different today. So, we've got a live Lightboard session for you. That's right. We're going to be going back and forth. Abhay is going to explain to me a little bit about MemoryDB with Amazon Controllers for Kubernetes, which is a pretty cool way to be able to manage your services directly from Kubernetes. But before we really get into all of that, Abhay, I think first off, I think we need to start with what exactly you do, what you do as a product manager, and a little bit about MemoryDB itself.
Yeah. So yes, as I said, I'm a product manager on the in-memory databases team here at AWS. We have two in-memory databases that we offer. And AWS offers in-memory databases as one of the more or one of the most performant databases for workloads that have extreme latency requirements and high availability and all of that good stuff. So, of course, a lot of the containerized and microservices applications do need all of that, and so I thought this might be a good venue to chat about all of this. So as I said, we have two services. MemoryDB for Redis is one, and Elasticache, which operates with both Redis and Memcached. So yes, two services that we offer here.
Awesome. And so, folks, again, if you're joining in right now, what we have here, we're going to be doing a live Lightboard session. If you catch me looking down, that's just because I have my laptop here, and that lets me look at Abhay, see some of the notes he might be posting, and also take a look at some of the comments that you may be asking. By the way, if you have any questions as we go through this presentation today, don't hesitate to go ahead and drop a question, drop a comment, and we'll get to it as soon as we can. But today we're trying something a little different. Abhay is going to help me visually explain some of these concepts. By the way, I do have to give a quick shout out to Whitney Lee over at VMware, who definitely pioneered this approach with having recorded Lightboard sessions with some of the experts and SMEs in the field explaining concepts to her. So I'm going to do my best to live up to the kind of quality that she set. But let's go ahead and get started. Abhay, I think very quickly, we probably want to start drawing out a little bit about exactly how MemoryDB or Elasticache itself works before we jump into the piece with ACK, AWS Controllers for Kubernetes. What do you think?
Yeah, sounds good. Yeah, let's walk through it. I think I don't know if most people watching are familiar with Redis. But Redis is one of the more popular database services out there as an open source software, and both MemoryDB and Elasticache are compatible with Redis. So I think it's interesting to walk through how they both work.
All right. So how about we start with Elasticache? And we'll say right here that I think the easiest way for folks to kind of understand where we're starting from here is to start with a client. So let's say this is a client. Maybe they're running a CLI tool or something like that. I mean, what's the best way to work with Elasticache? What are folks running on their machine?
Yeah, the most common or the most simple way to engage with Redis is usually the Redis CLI, right? So Redis CLI is an open source tool. You can talk to Redis, or you can use any of the open source Redis clients that might be embedded in your application that could be talking to Elasticache and MemoryDB. Yep.
Okay, so first things first, let's say that using the CLI, we want to store something in Elasticache. But very quickly, Abhay, Elasticache, what exactly are people using it for? I think as the name implies, it's a cache. Is that really all it's used for? I mean, what's kind of a simple way to understand when someone might even start to use something like this?
Yeah, it's a good question. So Elasticache, as you said, it's in the name, it's a cache, right? So it's intended to be used as a service or as a cache to accelerate access to your data that might be stored somewhere else, right? So for example, you might be using RDS if you've got a relational database, or you might be using DynamoDB if you've got a NoSQL database, and you might want to add a cache on top of it because you have, a really fast latency requirements. And so Elasticache acts as a cache on top of these services. You might sometimes use Elasticache as a ephemeral data store as well. Sometimes you just want to park data, for a short time in somewhere and to be able to read it very, very quickly. And you may not care about data loss, right? So as you can imagine, in a caching service, data durability isn't necessarily guaranteed, right? The data can be lost at any point. If you've got a use case where you just want to store data temporarily, for a few seconds to a few minutes and then get it quickly, and you don't care about the data loss, you might use Elasticache for those as well.
Okay, so I can kind of see where this is going. So let's say that we're using the CLI, and I think we talked about this a little bit before the show, but you mentioned that what a user first may want to do is a write action. So let's draw a little arrow here and say write. And so can you walk us through a little bit, what would that first step look like?
Yeah, so Elasticache and MemoryDB are NoSQL database services, right? So they usually operate in key value pairs, and we'll get into a little bit more detail because they are Redis compatible. But essentially, these are NoSQL in-memory databases. And so when a write comes in, so let's say your client is saying, hey, set A equals 100, the value of A to 100, right? What happens is you've got, as you just drew, you've got Elasticache there on a node, and Elasticache is going to store the value A equals 100 in memory, in RAM on that node, and immediately respond back with a success that, okay, I got that, A equals 100.
Okay, so I think that's a critical thing. It immediately responds back, and I think this is like an acknowledgement, right? So we'll just say acts, and not to be confused with AWS Controllers for Kubernetes, but an acknowledgement of the fact that it's been written. And so I think this is critical to understand, because when we start drawing the same thing out for MemoryDB, there's going to be a critical difference with the way it works. But with Elasticache, this happens immediately. As soon as the write happens, it acknowledges back, right?
Exactly, right.
Okay.
And so this is, as I said, these are Redis compatible services. So this could be a key value pair. Redis also supports, by the way, complex data structures. So it doesn't have to be a value. It could be something like a linked list, for example. It could be a hash map. So you could say, hey, set the value of A equals to this complex hash map, right? And all of that data is stored in memory, and we respond back immediately with an ACK. It is important to call out that data structure aspect because, let's say you're storing a hash map, and then in a subsequent write, you want to update a sub part of that hash map. You don't have to read that entire hash map and send it over the wire to the client. You can just say, hey, set this sub value to something else, and we can do that in memory directly, right? So, and because as you can see, the write is happening to memory and immediately responding back, the service is extremely fast. As RAM and memory is extremely fast, you get microsecond performance on both reads and writes here.
Got it.
Now,
so you had mentioned that this Elasticache is generally used for certain use cases, for maybe ephemeral data store where data loss is potentially not a drastic, catastrophic thing. Is it because is there any sort of replication or storage happening here? Are we storing this anywhere else? Because it seems like, we may want to have some sort of persistence here.
Yeah, as I said, it's intended to be used as a cache. So that's why the data is in memory for ultra-fast access. We do offer what is called high availability mode, right? So we don't want to make, because it's in memory, as you can imagine, if the node goes down, your data is lost. And that seems counterproductive for most workloads. So we do add, a certain high availability mode. So you can add replica nodes to your Elasticache cluster. And what Elasticache does is replicates your data from the primary over to the replicas, and that happens asynchronously, right? So, you might add, up to 5 replica nodes into the cluster, and Elasticache will asynchronously replicate that data, and that is completely transparent to the client. Right?
Okay, so let's draw it out something like that, and we'll say that this happens asynchronously.
Exactly. And now, because the data is replicated, this data is there for high availability. So for example, let's say your primary node becomes unavailable suddenly. Elasticache will automatically promote one of the replicas to become the primary. And that way you might see a slight blip in availability, but your node becomes immediately available, right? And you can also use the replica for reads. because the data is available there, you can issue reads against those replicas as well.
Got it. So we do have a question from the chat, and I actually recognize the name here. It's from Carlos Santana over at IBM. So he says, usually used on top of SQL databases, right?
Yeah, it could be used on top of any other database, really, SQL or NoSQL, because it's essentially intended to be used as a cache. So yes, you can store, serialized responses from SQL databases, or just key value pairs from NoSQL databases. Yeah.
Awesome. All right. So we've talked about Elasticache, and now I think it's important to let's jump into MemoryDB, and I think I want to understand exactly how it's different. And so we'll draw out the same piece, and we'll say we have a client here. Now this client, let's talk a little bit about the client itself. Again, are we using the Redis CLI again for MemoryDB?
Yeah, so MemoryDB is also fully Redis compliant with open source Redis, essentially. And so, yes, you could use the Redis CLI. You could use any of the Redis open source clients that exist and use those to talk to MemoryDB as well. Yes.
Got it. All right, so now let's try the same kind of exercise here. Let's say we want to write something, and we'll say we want to write, again, a equals 100.
Yep. So you want to write a equals 100, and in this case, the same thing happens. MemoryDB is also an in-memory database. Taking a step back, to be clear, we call MemoryDB a database. Right, the intended use for MemoryDB is as an in-memory database. You could use it as a primary database, unlike Elasticache, which is a cache, right? And so what happens when you write a equals 100 is we will write a equals 100 into memory on the primary node, as you're just drawing there, right? And then, but as we discussed previously, memory isn't durable, right? The node can go down and you might lose that data. Mm-hmm. But with MemoryDB, so to provide, because it's a database, what we do is we also write that data into what is called a multi-AZ transaction log.
Okay. So critical difference here. I sorry to interrupt you, but instead of immediately sending an acknowledge back, we're adding a different step here, right? And so I want to make sure I get this right. So synchronously, you had mentioned, we are also writing this to, you're going to have to say that for me one more time.
It's called a multi-AZ transaction log. So it's an internal service we've created to store data durably. So yes, a multi-AZ transaction log. And it's called multi-AZ because we store that data inherently across multiple AZs.
Got it. And why is that kind of so critically, that's the difference between Elasticache and MemoryDB. And as the name implies, as you said, it's a DB. That multi-AZ transaction log, is that adding to the resiliency, the durability of the data that's being stored?
Exactly that, yes. So, unlike Elasticache, where data is stored in memory, and if the primary node goes down, you lose that data. With MemoryDB, every write, every update to the data is stored durably in the multi-AZ transaction log. This multi-AZ transaction log is an internal service. It stores the data across at least 3 different availability zones in AWS before it responds back as a success. So every write essentially is persisted on disk in this multi-AZ transaction log. So as you've got there as a synchronous write, as soon as we've written it successfully across at least 3 AZs in that multi-AZ transaction log, we will respond back with a success to the primary node.
Okay, so at that point, once we've done that synchronous write, that's when we're kind of responding back. And so I can imagine this is probably going to add some transaction delay, some latency when compared to Elasticache. How significant is that?
That is right. It does take additional latency on writes. On Elasticache, writes take microseconds. On MemoryDB, writes take up to 3 to 4 milliseconds. So It is somewhat slower, but we usually expect all writes to complete within 3 to 4 milliseconds. P99 we've observed is roughly around 7 to 8 milliseconds. So yes.
Okay, so how about I just write microseconds and milliseconds here, because we're on an order of magnitude difference of how quickly we're getting back the data here. Okay, so I think there's more for me to draw here though, right? Because although we're storing this as a multi-AZ transaction log, we still want to store the data, right?
Yeah, so as in Elasticache, you can also create replicas on MemoryDB. Right? The reason you would do replicas is to get high availability of MemoryDB and to be able to scale out your reads. Right? So you can issue reads against replicas to be able to scale out your reads as well. So similarly, you can have replicas here as well.
Okay, so you had mentioned that in Elasticache, this would only be in high availability mode. Is that so? This is kind of an optional piece when using Elasticache?
Yeah, the reason you would add a replica to Elasticache or MemoryDB is either for high availability mode or to get read scaling. Right? So high availability mode really just means that, hey, imagine if you don't have replicas, you've got only the primary, right? And if the primary goes down, you've lost your data in Elasticache. And in MemoryDB, the data isn't lost, but we will still have to provision a new primary node and get all the data back from the multi-AZ transaction log before it becomes available, right? So that will take time. And so your service will be unavailable during that time. But if you had replicas, we can immediately promote one of the replicas to become the primary. And that way you avoid downtime.
Okay. All right. Is that same theme also apply for MemoryDB? The replicas, it's an optional high availability thing?
Exactly. Yes. So replicas act as an optional high availability thing. So in this case, let's say the primary node goes down. What happens is MemoryDB will automatically promote one of the replicas to become the primary, usually within a few milliseconds, right? So you would barely see any downtime, and one of the replicas becomes the primary. Before we promote to primary, though, the replica actually reads all of the data, the latest data from the multi-AZ transaction log, and so it is fully caught up to the primary before it becomes the primary.
Got it. I think we have to talk a little bit about cost. When we compare things like Elasticache and MemoryDB, and we also talk about things like the high availability, what is a user's metric? What's their KPI? What are they measuring, especially when it comes to things like optimizing spend?
Yeah, so both services charge for essentially instance hours. So you choose EC2 instances to run Elasticache or MemoryDB. And you choose EC2 instances based on the amount of data you want to store in these services, the amount of throughput you need, and so on. And so we charge per hour for EC2 instances for both services. And for MemoryDB, there is an additional charge for every gigabyte of data that is written. And that is to cover our costs for writing to the multi-AZ transaction log.
Okay.
In terms of pricing, the difference is that MemoryDB, yes, is slightly expensive because it offers stronger durability guarantees and it is intended to be used as a database. So if you need an in-memory database, you would go with MemoryDB. If your use case, for example, cannot afford data loss, you would use MemoryDB. If you need a cache, you would use Elasticache.
Got it. Understood. And folks, it looks like I might have cut off a little bit down there, but again, we're doing it live here. I just wrote that, we're going to be charging based on EC2 instance hours, and MemoryDB has an additional kind of that gigabyte usage. And also, I'm assuming here it would make sense for these replicas in the high availability mode, you're being charged for the instance hours and again, the gigabyte usage for MemoryDB. Is that right?
That's right. So the replicas essentially count as additional instances. So the total number of instances that you set up, you pay per hour for those instances for both services.
All right, awesome. So we did get a question in the chat, and I think it's a perfect time to kind of highlight this. We got a question from Arthur Mann saying that he assumes MemoryDB multi-AZ transaction log service is an AWS managed service. But specifically, if I understand right, the service itself is MemoryDB for Redis, and that's kind of a specific feature. Maybe I can let you answer the rest.
Yes, so both MemoryDB and Elasticache are fully managed services that we offer to customers. The multi-AZ transaction log is an internal-only service that we use internally to store MemoryDB data durably. Right? So we're talking about it here just to explain how we achieve durability with MemoryDB. Right? But it's an internal service that we use to store the data.
This is kind of a detail, but the service itself, MemoryDB for Redis, and of course, being a managed service, I think the assumption here is that AWS is going to be responsible for the the undifferentiated heavy lift of managing the nodes, the EC2 nodes themselves, things like installing the necessary software, managing and providing the customer with an SLA, which, by the way, do you happen to have that off the top of your head, the SLA that you can offer?
Yes, we offer 3 nines of SLA for both services, assuming you're operating in high availability mode, where you have at least a few replicas for each service. But we offer 3 nines of SLA for both services.
There we go. Awesome. Perfect. All right. So Abe, we've, I think, done a great job here with your help of hopefully explaining the difference between Elasticache and MemoryDB. Hopefully this is coming through clear enough for folks to be able to understand. But realistically, I think when we want to summarize when a customer would want to use Elasticache versus MemoryDB, I think very quickly, maybe Abe, could you give us a couple of use cases for when you would want to take advantage of this more ephemeral, faster microsecond response time, Elasticache versus MemoryDB, which has some of that additional HA capability with the multi-AZ transaction log, and obviously a little bit slower on the response time.
Yeah, and just to clarify the little bit slower aspect, the writes are a little bit slower for MemoryDB. The reads are just as fast because reads are happening from memory. So just wanted to clarify that point there. So reads are still microseconds, writes are milliseconds for MemoryDB. But I think, yeah, it's a good question about which service you would use when. So Elasticache, as we discussed, is a cache, right? So the primary use case would be you want to add a cache on top of another database that you're using to accelerate data access speeds. Right? So your application, you might realize, hey, your application is too slow. You might want to add a cache and get microsecond performance. That's really the primary use case for Elasticache. There are other use cases where you might store data temporarily in an ephemeral way where data loss isn't potentially a concern. For example, because it is Redis compatible, Redis offers a data structure called a leaderboard. So, for example, you might be operating a game, and you might want to store user, stats. Like, hey, you've got 10 users, and who's the number 1 player, number 2, and number 3, and you can store that data directly in Elasticache as a ephemeral store for the duration of the game, right? And you can operate that leaderboard directly in memory. So that's an example of an ephemeral, data store where it's stored for a few seconds to a few minutes, and data loss. If the data is lost, for example, that's totally okay. You can recalculate the user, the game stats immediately and render it for the user. MemoryDB, on the other hand, is intended to be used as a primary database. So you would use MemoryDB for where you need both speed and you need a database, right? So traditionally, how you would have accomplished this is the previous architecture where you add a cache on top of another database. With MemoryDB instead, you can now just have one service. You've got a database, and it is fast because it's storing all data in memory, right? So one of the primary use cases we've observed is customers essentially replacing their data architecture completely. So instead of having a NoSQL database and a cache on top, now you can just use MemoryDB. That's one use case. In specific customer use case, talking in terms of specific customer use cases, one of the big ones is using MemoryDB as a durable store for microservices communication. This one's come up quite a bit amongst our customers, right? So let's say you've got an architecture that has hundreds of microservices, and traditionally microservices talk to each other, in a decoupled fashion, and so usually asynchronously. Right? And so how do you pass these messages between microservices? Hey, you can use MemoryDB. It's going to guarantee that the data is stored durably, and it is going to make sure that your microservices are super fast because you can read and write those messages extremely quickly and scale as much as you want. So as a durable store or a messaging backbone between microservices is a big use case. Another one is a durable session store. Hey, you've got customer session data, whether it's on an e-commerce website, whether it's on the user behavior on a website, but you don't want to lose that data at any point. And at the same time, you want ultra-fast access. You might want to store that data in MemoryDB as a durable session store. So those are some of the use cases for MemoryDB.
Perfect. And we actually got one more question in the chat. And before we jump to the AWS controllers for Kubernetes piece and how that ties into this, It's actually funny. That's kind of what we're having Abe on today, is to kind of announce his news preview support for ACK. But before we get into that, really quickly, one last question here from Raphael. What are the benefits and drawbacks of MemDB compared to Aurora?
Yeah, so Aurora is a relational database, whereas MemoryDB is a NoSQL database. So without getting into the pros and cons of NoSQL versus relational, that has its own deep topic, you would use something for something like MemoryDB when you need a really fast database, when ultra fast performance, the microsecond performance is really important for your application, right? And your data relationships are fairly straightforward, and so a NoSQL database sort of makes sense in those cases. That's when you would use something like MemoryDB. You might use Aurora when you've got a more complex data relationship and data structure to store, and so you do need that relational database. And speed is maybe of less importance. Now, if you do need ultra fast speed on Aurora, you might be able to add a cache, right, on like Elasticache on top of Aurora to achieve speeds as well. So that's really, the comparison of something like a MemoryDB and Aurora.
Gotcha. And from my perspective, for example, I'm working with the comments here directly, and comments, we need them to be kind of fast, and I could see them being a very simple structure: A equals B. This user has this comment. That can be something that's kind of perfect for something like MemoryDB, where you probably want to store that chat for long-term usage, but you also need it to be pretty fast. Whereas compared to, say, user login information and structured tables, it might make more sense when you want to use something like Aurora, have that structured relational database style. All right, so we're on to the second half of the presentation today, and I want to pass it back to you, Abe, for what exactly are we excited about today? We have this title, AWS Controllers for Kubernetes. What have we announced?
Yeah, so we recently launched the ability for you to control MemoryDB resources from Kubernetes directly in your application. So if you've got a containerized application and you're using Kubernetes to operate and manage your resources, now you can operate and manage MemoryDB resources directly from your Kubernetes cluster as well. This means that, hey, the reason we're doing this is, we think MemoryDB and Elasticache are really well suited for applications that are, built using the microservices patterns as well as using containers, right? And so we want to make it easier for customers who are using things like Kubernetes to operate MemoryDB and Elasticache. And so in that vein, we're launching this controller for Kubernetes for MemoryDB. And you'd be able to manage MemoryDB resources directly from Kubernetes.
Yeah.
The use case, for example, that I mentioned, where you've got a set of microservices that want to communicate with each other, and you want to use MemoryDB as a messaging backbone. Well, hey, now you can set up MemoryDB directly as part of your Kubernetes, workflow, which is setting up those resources.
Right, and the reason why that's so powerful is because you got to imagine, as an operations team, you have skills, expertise with Kubernetes, and you're deploying microservices in Kubernetes, and you have YAML, and your systems are built around this declarative YAML way of managing resources. And then when you want to include a managed service, something on AWS like MemDB, if you're going with traditional approaches of managing that MemDB, you have to use things like imperative approaches. Traditionally, maybe you have a CLI or the console where you're clicking through steps to set up the MemDB. And so you lose some of that connection between the way you manage Kubernetes workloads and the way you manage these managed services. And I always bring it back to one thing that Kubernetes does really well amidst hundreds, and it's the control loop. And I've talked about this so many times in my Lightboard videos, but the first step of the control loop is going to be to observe. Let's use a different color here. And the second step is going to be to do a diff. And so very quickly, Abe, not to distract from the presentation here, but I want to outline, here's what Kubernetes is doing. It observes the YAML you pass in. And traditionally, this can be things like Kubernetes deployments and services and ingresses and that kind of thing. And this control loop is always going. We haven't finished it out yet, but Kubernetes then does a diff to compare that YAML, that declarative kind of configuration you passed into what actually exists in the cluster. It does a diff, and it realizes, at least the first time you deploy it, that it doesn't exist. and then it acts on it. And this control loop is always happening in Kubernetes. And I think what we want to do today is show how you can leverage the Kubernetes control loop, we'll even say right here, control loop, to manage resources that are not even native Kubernetes resources. Of course, Kubernetes natively comes with things like deployments and services and pods, things that we know and love. But what about things that are outside of the context of Kubernetes that are running in AWS as managed services, things like MemoryDB and Elasticache? And so that's what's really cool about AWS Controllers for Kubernetes is it allows you to use this control loop to manage these services. So Abe, let's walk through it step by step. Now, I know that before you ever even start writing the YAML, the resources to deploy one of these things, you have to configure the cluster itself, right? And so I like to lay this out into two different personas, and maybe you could work with me here. We're going to start with the dev persona up here. Let's make sure I'm not out of frame. Here we go. And we'll start with the ops persona right here. And of course, ops is going to be responsible for setting up the cluster to make sure that the right things are there to be able to even authenticate with AWS. So let's start with that piece right here. Let's say we've got a Kubernetes cluster over here. What's the first thing that the operations team needs to do to set the Kubernetes cluster up to be able to use ACK from MemDB or Elasticache?
So you would, the operators would set up your Kubernetes cluster as we would normally today, right? And you would need to import the AWS controller for Kubernetes for MemoryDB in there, and which will give you the control to be able to manage MemoryDB clusters alongside everything else.
Okay, so let me draw that out first. So let's say MemDB ACK controller. And so this is the first thing that the user needs to actually set up on the cluster itself. Now, obviously, we need to authenticate this to AWS somehow, right? So let's say over here, we'll draw out a little cloud, and we'll say that this represents AWS. Now, of course, by the way, this Kubernetes cluster could be Elastic Kubernetes Service, EKS, on AWS, or it could be basically any Kubernetes cluster running anywhere. There's no limitation to use ACK to work with services on AWS. And so let's say this is AWS services, things like MemDB and Elasticache. So let's talk about this piece right here. So when you set up the controller, what do we need to do to make this piece work?
So there are a few steps, right? So you would first download and install the ACK controller, and you would have to then make sure that the controller has permissions to access AWS services, including MemoryDB. So that's probably step number one.
All right, so the ops engineer, as you mentioned, first installs the controller into the cluster and then configures the controller to be able to authenticate with AWS. Now, again, folks, this is way before the dev has even created any custom resources, CRDs, anything like that. We're simply setting up the clusters so that there's a controller that's running through this control loop continuously, observing the config, doing a diff, and acting on it. And then that's going to authenticate with AWS services. And I have to know that this is using IRSA, which is IAM roles for service accounts, just a fancy way of saying that we're connecting Kubernetes service accounts with IAM roles in AWS to kind of authenticate and connect the two.
Yep, that's exactly right. So, and this is a one-time thing. You set it up, make sure that the ACK controller from MemoryDB has access, and that your Kubernetes cluster can act on behalf of MemoryDB to create those MemoryDB clusters. Yep. Okay,
so let's get to the fun bits. So the ops team, they did the boring stuff. They got the cluster ready. They said, okay, developers, we've made it baby-proof for you. All you need to do now is deploy some configuration. So let's walk through that step right there. What does the dev who, as you mentioned, maybe they're deploying some microservices and they want to use something like MemDB to handle communication, or maybe they have a gaming app and they want to store leaderboards, stats, whatever the use case might be. The dev is working on dev stuff and they say, look, I need a data store. So what does the dev do to kick this into action? And hey, real quick before I jump to that, I should say that this is the MemDB ACK controller. But if they wanted to deploy something like Elasticache, they will need to deploy another ACK controller. So I do want to make sure I draw that out real quick.
That's exactly right. Yep, there's two separate controllers for the two services. So if you want to instantiate and manage Elasticache resources, you would need the Elasticache ACK controller, and otherwise you would need the MemoryDB ACK controller. So yeah, let's chat about what happens next. So MemoryDB ACK controller operates the same way. You would, in its simplest form, you would create a very simple YAML file which contains the details of the MemoryDB cluster that you want to create, right? So in its most basic form, it would have things like the name of the MemoryDB cluster and the number of nodes you want and the type of the node that you would want. And you would just enter all of that into a YAML file and have the MemoryDB ACK controller executed, and that will just create that MemoryDB cluster for you on AWS.
Okay, so let me draw that out real quickly. So the dev writes out this YAML file. This is a YAML file defining the MemDB or Elasticache file, and so things like the name, the number of shards, replicas, just some things configuring the MemDB itself. One critical thing I want to point out, though, folks, is that this dev doesn't need to know any of this piece right here. They simply need to be able to authenticate with Kubernetes itself. And so I'll draw that out real quick here and just say RBAC. Here's the two different authentication schemes. So although the controller uses IRSA to communicate with AWS, the dev doesn't need to know what account it is or anything like that. The ops team is taking care of it, and they just need to authenticate with RBAC. Obviously, this is going to go to the control plane. That's where the API server of Kubernetes is. That, in turn, is going to store it in its etcd. Maybe I'm going into a little bit too much detail here. That doesn't necessarily, it's a little inconsequential here, but regardless, we'll do it for completeness. So the control plane receives the YAML, and folks, the control loop kicks in right now, right? It's observed the YAML that's come in. It does a diff. It realizes there's no MemDB instance in AWS, but the dev wants one. And so it's going to act on that difference. And it does that when it passes it to the controller, and the controller acts on it, and it kicks off that flow. Anything that we're forgetting here, Abe?
No, I don't think so. I think, the interesting piece is all in the YAML. You describe what kind of cluster you want to create, how many shards you want in your database, how many replicas you want in each shard, what kind of instances you want. You specify all of that, put it into your YAML file, and the loop kicks in and deploys or instantiates that cluster over onto AWS.
Okay, let's quickly write those out. So you said we want the name of the MemoryDB, obviously. We want the shards. What exactly are the shards? What is that referring to?
Yeah, we didn't chat about that earlier. Shards is a database concept where you can essentially, split up your data, if you will, into multiple sections, and that gives you the ability to sort of scale out your database, right? So both MemoryDB and Elasticache support scaling out. So you can create multiple shards, up to hundreds of shards of data, and that way you get two things. One, you get scaling out, meaning you can create, for example, if you've got a database which has gigabytes or terabytes of data, you can create multiple shards, and each of them can have their own read replicas, and you also get higher availability. Right. So let's say one shard goes down, then only one out of your total number of shards is unavailable. Right. So let's say you've got 100 shards and one goes down, your complete database isn't down. Only one shard is down. So it gives you high availability with sharding as well.
So help me understand it by coming back to the drawings here. So the shards are really referring to this piece right here, the primary node, and that itself can be kind of replicated in itself into multiple shards or nodes?
Well, so not just the primary, it's the primary and the replicas. That set is a shard. So what you've drawn here essentially is a single shard database cluster,
Got it.
right? Now, if you had multiple shards, you would have the same thing split. Let's say you've got a 2 shard cluster. You would have the whole setup again replicated on the side. Well, replicated is the wrong word, but let's say you've got the database split into 2 primary nodes and 2 replicas each. Your client, the Redis client, will have intelligence to talk to which, it will know which shard to talk to. And Redis essentially gives you that intelligence of multi-sharded, or what is called cluster mode enabled in Redis, right? So what it will do is, hey, key slots, for example, 0 to 100 belong on shard A, and key slots 100 to 200 belong to shard B. And so if you try to write to key 150, it will automatically go to shard B, and so on and so forth. So that way you can scale out your database to as many shards as you'd like.
Got it. Okay, so we've got the MemDB YAML right here. And so we mentioned we need the name, we need the shards. Now, I quickly ran through the docs before I jumped on here. I remember there being another one called replicas. So if we're already defining shards, what exactly does replicas define?
So each shard has a certain number of replicas. So as in your drawing on the left, you've got each shard has 2 replicas right now. So you would specify how many shards you want, and you would specify how many replicas per shard do you want. So for example, you could say, hey, I want 2 shards with 2 replicas each, which means each shard will have 3 nodes, right? 1 primary and 2 replicas, and you have 2 shards. So you would have a total of 6 nodes that will be comprising your cluster.
Perfect. All right. Off the top of your head, so we talked about name, shards, replicas. Anything else in the YAML that the user should know about? What else are they defining in here?
Those are the required pieces. Now, there are some other optional pieces that you could configure. For example, a big one is the VPC that you want to operate your MemoryDB cluster in. So by default, MemoryDB will pick your default VPC and create the cluster in that VPC, and it will be accessible only in that VPC. You could point the cluster into a different VPC as well and give us the VPC ID. We will create it there. And another additional optional field is the security groups. So you can also configure security groups that can access your MemoryDB cluster, and you can provide that in here as well. There are a whole bunch of optional fields that you can configure that's available in the API definition. So if you want to set them up, you can read through the API definition and put them in the YAML.
Cool. So just quickly, the VPC, I may want to, for example, let's say I'm running this Kubernetes cluster as a managed service on AWS, let's say on EKS, and it's running in a specific VPC, and I want those pods to have very, very low latency to the database. That could be a good reason for me to want to configure that VPC, right? We want to make sure those nodes are in the same VPC that my cluster workloads are running in.
That's right. Yeah, that's a pretty good reason you want to do that. And of course, security being the other reason.
Sure, definitely. Can never forget about that. All right, so I think we've got basically as much as I can draw in here before I start drawing on my face. I think we have a very good overview of this. I saw a couple comments in the chat come up, and I think maybe we need to reiterate this point. Why would you want to use Kubernetes to manage the lifecycle of Elasticache for MemoryDB? Why not just do things, the standard way? Why not use Terraform? Why not use CloudFormation? Why not, do it in the console directly? Why ACK?
Yeah, I think the short answer is that now you can plug this into your regular Kubernetes workflow, and you don't need custom code, custom processes, custom workflows to manage MemoryDB, right? For example, if you were operating your resources on AWS using Kubernetes, and let's say you wanted to deploy MemoryDB, you would either have to write custom code, using Terraform or using the CDK, or even manually go in and create these clusters using the console or the CLI and then plug that in, which adds overhead, right? It adds operational complexity. If you've got a somewhat large organization, all the stuff you talked about, here, the separation of concerns between the operators and the dev, all of that becomes extremely complex to manage. And with Kubernetes, with ACK, for MemoryDB, you can now plug this in directly into your Kubernetes workflow, and you get the benefit of essentially, managing infrastructure as a service for MemoryDB as well.
Yeah. So let's draw it like this. Maybe we could say alongside your MemoryDB YAML, we're also going to have microservice A and B and C, and then their related, services as well.
Exactly.
And all of these are also Kubernetes resources in YAML, and maybe you're plugging them into some sort of automation workflow, whether it's Argo CD or maybe something like Travis, whatever it might be. And so now this application, which has a dependency on that MemDB, can also be deployed right alongside. Right? So your services, your microservices, your deployments, pods, services can be deployed right alongside their dependencies. And so that life cycle is just that much simpler. I like to call this simplifying cognitive dissonance. Essentially, it can be very complex to manage multiple different life cycles of deploying software and the dependencies. But by using ACK, we can simplify all of that into kind of a single type of declarative YAML approach. We all love the way that Kubernetes manages the lifecycle of resources. So why not leverage that for MemoryDB and Elasticache? So we have some great questions.
Sorry, go ahead.
So I just wanted to jump into some questions real quick. Do you want to talk about something before we do that?
No, let's do the questions.
Cool. Awesome. So I got a great question here. Just going through the documentation, it seems trivial to add more shards via the ACK controller. How come there's no support for auto-scaling? It's a question from Sri Lakshmi.
Yes. So yes, adding or reducing shards, even adding replicas. So if you want to scale out or just scale your reads by adding replicas is fairly straightforward. You just change the YAML, it redeploys and scales out immediately. And all scaling out is online. So your service sees no downtime. It'll automatically scale out. We don't support auto scaling yet. That is true. But yeah, customers can completely manage this on their side. If they can continuously monitor, for example, their memory use and their CPUs on the MemoryDB cluster, and automatically scale out when they observe that they're nearing the limit of their resources. And that's fairly straightforward using the ACK for MemoryDB. But yes, we do not support auto-scaling for MemoryDB today. We do support auto-scaling for Elasticache though. So you can create auto-scaling rules for Elasticache. So you can say, for example, hey, automatically, you can set up rules based on time, or you can set up rules based on metrics. So you can say that, hey, scale out every Friday at 10 a.m. because I see a whole bunch of traffic then, and scale back in at 10 p.m. on Friday. Or you can do it based on metrics and say, hey, if my memory usage hits 75%, then scale out. So those auto-scaling rules are available for Elasticache, not yet for MemoryDB.
Awesome. Now we got another question from Sri Lakshmi. Before I jump into it, it is referencing the Saga pattern, which I am not familiar with myself to much extent. But can MemDB provide support for the Saga pattern of microservices and event sourcing architectures?
I'm not super familiar with the Saga pattern as well. So I can take that question offline, and maybe I can reach out offline and answer that question.
Yeah, maybe this is a good time to talk about how people can get in touch with yourself and the MemDB team or the Elasticache team. I'm sure folks have questions, or maybe you want to get in touch to ask more questions. Can you talk a little bit about how they can get in touch with you or the team?
Yeah, so I'm on LinkedIn. I think we can paste my link here, but you can find me on LinkedIn, and I'm happy to reach out and answer questions there. The team is available via email at memorydb/help@amazon.com. So feel free to reach out directly to us via that email address, and we are happy to respond and get in touch and help you get set up with either of those services. So yeah, that's probably the best way.
Awesome. And I have a couple of these snippets that I got from your team that I'll post right here. Right there, we're going to have a link to download the ACK container image, as well as that email that you had just mentioned. Abhay, do you want to quickly talk about that container image and how you can use it to get started?
Yeah, you can download that container image and essentially use ACK and get started usually within minutes, right? If you're familiar somewhat with how Kubernetes operates, you can just download that image directly and get started within minutes. Yeah.
Very cool. All right, Abhay, we're coming close to the end of our time here. Folks, if you have any more questions, please don't hesitate to drop them in the chat here. But before we sign off, Abhay, any last words you want to leave folks with here? Any call to actions, anything that they can do to get started today?
Yeah, so we offer a free trial for both of these services. So if you're curious how these services work, test them out, go to aws.amazon.com, your console, and you can get started with both of these services for free and test them out. As I said, in-memory databases are great if you think your application is too slow and you want ultra-fast performance and scale. You can pick Elasticache if you need a cache, and you can pick MemoryDB if you need a highly performant database. So yeah, try it out today. It's available for free. And yeah, happy to answer any questions. I think my contact and the team's contact is in the chat. Please reach out.
Awesome. Abhay, I want to thank you so much for joining me today. I know this is a little different of a format than we usually do. Hopefully the viewers at home enjoyed this, or the office, wherever you might be tuning in. We definitely want to do more of these in the future. If you enjoyed it, please be sure to drop a comment. Be sure to subscribe to us, and we'll try to do more of these in the future. Let me know if it worked for you. Now, again, Abhay, thank you so much for joining me. And folks, stay tuned for more episodes in the future. Thank you.
Thanks, everyone.